The three-light traffic signal. Garrett Morgan invented an automated traffic control system that introduced the yellow caution light between red and green signals. It consists of a T-shaped pole with three light positions that cycle automatically to regulate vehicle and pedestrian movement at intersections. The system works by providing a warning interval with the yellow light, allowing drivers time to slow down before the signal changes to red. This prevents sudden stops and reduces collision risks at busy crossroads. Morgan patented his design in 1923 after witnessing a serious accident at a Cleveland intersection. His invention differed from earlier two-light systems by adding the transitional yellow phase, which created a buffer period for traffic flow. The mechanism involves timed electrical switches that control each light's duration based on traffic patterns. Morgan's device was manually operated initially, but established the foundation for fully automated signals. The three-light system became the international standard for traffic control, adopted by cities worldwide throughout the 1920s and 1930s. Morgan eventually sold the rights to General Electric for $40,000, and his design principles remain essentially unchanged in modern traffic management systems that now incorporate digital timing and sensors. The carbon filament. Lewis Latimer developed an improved carbon filament for incandescent light bulbs that made electric lighting durable and economically viable. It consists of a carbonized fiber enclosed in a vacuum-sealed glass bulb that glows when electrical current passes through it. Latimer's innovation involved a process for manufacturing filaments from cotton or bamboo fibers, treated at high temperatures to create carbon threads. His method produced filaments that lasted significantly longer than Edison's original paper filaments, which burned out after just a few hours. The technique involves coating the carbon thread to prevent breakage during manufacturing and installation. Latimer patented his process in 1882 while working for the U.S. Electric Lighting Company. His filaments could burn for hundreds of hours, compared to the brief lifespan of earlier designs. This advancement made electric lighting affordable for homes and businesses, rather than remaining a laboratory curiosity. Latimer also drafted the patent drawings for Alexander Graham Bell's telephone and supervised the installation of electric light systems in New York, Philadelphia, and London. His manufacturing methods became the industry standard and remained in use until tungsten filaments replaced carbon in the early 20th century. The blood bank. Dr. Charles Drew pioneered techniques for processing and preserving blood plasma that established the modern blood banking system. It involves separating plasma from whole blood and storing it under refrigeration for extended periods without deterioration. Drew's methods work by using centrifugation to isolate plasma, which can be stored longer than whole blood and doesn't require blood type matching for transfusions. This discovery happened during his research at Columbia University in the late 1930s, when he developed protocols for large-scale blood collection and storage. The process includes anticoagulants to prevent clotting and sterile containers to maintain purity. Drew directed the Blood for Britain project during World War II, shipping thousands of plasma units to treat wounded. L.L. Dyers. He then established the American Red Cross Blood Bank program, creating standardized procedures for collection, testing, and distribution. His organizational systems included mobile blood donation units and refrigerated storage facilities. Drew's techniques proved especially valuable in emergency medicine and surgery, where immediate transfusions save lives. The infrastructure he built became the template for blood banks worldwide, and his preservation methods remained standard practice for decades until modern synthetic alternatives emerged. The gas mask. Garrett Morgan invented a safety hood that protected wearers from smoke, toxic fumes, and hazardous gases in dangerous environments. It consists of a hood covering the head and shoulders with a tube extending to ground level, where air is cleaner during fires. The device works by allowing the wearer to breathe air from near the floor, where smoke and heat rise upward, leaving cooler oxygen-rich air below. Morgan patented the design in 1914, incorporating a wet sponge filter to cool incoming air and remove particulates. The mechanism includes an inhalation tube with a valve system that prevents contaminated air from entering. Morgan famously demonstrated the effectiveness of his invention in 1916 during a tunnel explosion rescue in Cleveland, where he and his brother saved workers trapped by toxic gases. Fire departments across the United States purchased his safety hoods after this dramatic rescue. The military adapted his design for gas masks used during World War I to protect soldiers from chemical warfare. Morgan's invention established fundamental principles still used in modern respirators and self-contained breathing apparatus worn by firefighters, miners, and hazardous material workers worldwide. The automatic gear shift. Richard Spikes invented an automatic gear shifting mechanism that simplified vehicle operation by eliminating manual clutch engagement. It consists of a system that automatically changes transmission gears based on vehicle speed and engine load without driver intervention. The device works through a series of hydraulic controls and planetary gear sets that respond to accelerator pressure and road conditions. Spikes patented his automatic gear shift in 1932, though he had been developing transmission improvements since the 1920s. His mechanism includes a fluid coupling that replaces the mechanical clutch, allowing smooth power transfer between gears. The technology addresses the difficulty many drivers experience with manual transmissions, particularly in stop-and-go urban traffic. Spikes. Design incorporated principles that manufacturers later refined into the fully automatic transmissions introduced in the 1940s. His system used centrifugal force and hydraulic pressure to determine optimal shift points. The invention made driving accessible to people who struggled with coordination required for manual shifting. Modern automatic transmissions descended from concepts Spikes pioneered, now featuring electronic controls and multiple gear ratios. His work also included patents for automobile directional signals and an improved braking system that contributed to overall vehicle safety. The home security system. Marie Van Britten Brown invented a closed-circuit television security system that allowed homeowners to monitor visitors and control door access remotely. It consists of a motorized camera with multiple peepholes, a television monitor, a two-way microphone system, and a remote door lock mechanism. The device works by transmitting live video feed from the door camera to a monitor inside the home, allowing residents to see and communicate with visitors before opening the door. Brown patented her system in 1969 while living in Queens, New York, where high crime rates and slow police response times motivated her invention. The mechanism includes a sliding camera that adjusts to peepholes at different heights to view adults or children. Her design incorporated a wireless radio-controlled feature to unlock doors from a safe distance and an alarm button to contact police immediately. Brown's system established fundamental principles used in modern home security technology, including video surveillance, remote monitoring, and integrated alarm systems. Her patent became the basis for subsequent security innovations that added motion sensors, digital recording, and internet connectivity. Contemporary doorbell cameras and smart home security systems descend directly from concepts Brown pioneered in the 1960s. The pacemaker control unit. Otis Boykin developed an improved electrical resistor and control unit that made cardiac pacemakers reliable and precise in regulating heart rhythms. It consists of a wire precision resistor that withstands extreme temperature changes and controls electrical current with exact specifications. The device works by sending precisely timed electrical impulses to heart muscle, maintaining steady rhythm in patients with irregular heartbeats or cardiac conduction problems. Boykin patented his resistor design in 1959 after years of research into electrical component reliability. His mechanism involves variable resistors that adjust electrical flow to match individual patient needs without overheating or failing. The technology addressed major problems with early pacemakers that malfunction due to oscillators, temperature fluctuations, and imprecise current control. Boykin's resistors also found applications in guided missiles and computers, demonstrating their versatility and durability. His innovations made pacemakers small enough for implantation and dependable enough for long-term use. The control units he designed reduced the failure rate significantly and extended battery life. Modern pacemakers still utilize principles from Boykin's resistor technology, now combined with microprocessors and programmable features. His work saved millions of lives by making cardiac rhythm management devices practical for widespread medical use. The folding cabinet bed. Sarah Good invented a folding cabinet bed that converted from a functional desk into a sleeping space, addressing urban housing limitations. It consists of a wooden cabinet with compartments for storage that unfolds to reveal a hidden mattress and sleeping platform. The mechanism works through hinges and a folding frame that allows the bed to collapse vertically into the cabinet when not in use. Good patented her design in 1885, becoming one of the first African American women to receive a U.S. patent. Her invention targeted apartment dwellers and people living in small rooms who needed furniture serving multiple purposes. The device includes shelves for books, writing materials, and personal items that remain accessible whether the bed is deployed or stored. Good's design incorporated a desk surface on the cabinet exterior for daytime work activities. The folding mechanism secured the mattress firmly to prevent accidental collapse during sleep. Her innovation pioneered the concept of space-saving multifunctional furniture that became essential in urban environments. Modern Murphy beds and convertible furniture systems descended from principles Good established. Her cabinet bed demonstrated that furniture could be both practical and efficient without sacrificing comfort or functionality in cramped living quarters. The ironing board. Sarah Boone invented an improved ironing board with a narrow curved shape specifically designed for ironing women's clothing. It consists of a padded board with a tapered design that fits into sleeves and around curved garment sections like shoulders and waistlines. The device works by providing a firm surface that conforms to clothing contours, allowing for smooth wrinkle removal without creating new creases. Boone patented her design in 1892, addressing limitations of flat wooden boards or tables used previously for ironing. Her mechanism includes collapsible legs for easy storage and height adjustment for user comfort during extended ironing sessions. The curved edges and narrowed shape allow the board to slip inside shirt sleeves and pant legs for thorough pressing. Boone's design feat used a padded cover that protected delicate fabrics from scorching and provided cushioning for better heat distribution. Her innovation became the standard configuration for ironing boards manufactured throughout the 20th century and continues today. Modern ironing boards retain the essential shape and proportions Boone established, adding features like heat-resistant covers and mesh surfaces. Her practical understanding of garment construction and ironing challenges led to a tool that fundamentally improved household efficiency and clothing care for generations. The lawn sprinkler. Joseph Smith invented a rotating lawn sprinkler system that automated yard irrigation through mechanical water distribution. It consists of a central hub with rotating arms that spray water in circular patterns, covering large areas without manual repositioning. The device works by using water pressure to drive internal gears that rotate the sprinkler heads, creating even coverage across lawns and gardens. Smith patented his design in 1897 when urban residential landscaping was becoming increasingly popular but labor-intensive. His mechanism includes adjustable nozzles that control spray distance and pattern, allowing customization for different yard sizes and shapes. The rotating action prevents oversaturation in any single spot while ensuring consistent moisture distribution. Smith's invention eliminated the need for hand watering with hoses or carrying watering cans across large properties. His sprinkler design incorporated durable materials that withstood constant water exposure and mechanical wear. The technology made lawn maintenance accessible to homeowners without dedicated gardening staff. Commercial agriculture also adopted rotating sprinkler principles for crop irrigation on a massive scale. Modern lawn sprinklers retain Smith's basic rotating mechanism, enhanced with timers, underground systems, and smart controllers. His invention transformed landscaping from an elite luxury into a standard feature of suburban homes worldwide. Open heart surgery technique. Dr. E.S. Daniel Hale Williams performed the first successful open-heart surgery in 1893, establishing techniques for cardiac procedures still used today. It involves surgically opening the chest cavity to access the heart directly for repair of injuries or structural defects. The procedure works by carefully cutting through chest tissue and the pericardium to expose the heart, while maintaining patient stability through anesthesia and bleeding control. Williams performed his groundbreaking operation at Provident Hospital in Chicago on a stabbing victim with a knife wound near the heart. His technique included suturing the pericardial sac without rupturing the heart muscle itself, demonstrating that cardiac tissue could be surgically manipulated. The surgery required precise anatomical knowledge and steady hands to work on a beating heart without modern imaging or bypass machines. Williams pioneered antiseptic surgical practices that prevented infection during such invasive procedures. His patients survived and lived for decades after the operation, proving that heart surgery was medically viable. Williams founded Provident Hospital as the first interracial medical facility in the United States and established training programs for African American surgeons. His techniques established fundamental principles for thoracic surgery that evolved into modern cardiac procedures, including bypass surgery, valve replacement, and transplantation. The refrigerated truck. Frederick McKinley Jones invented a portable refrigeration system for trucks that enabled long-distance transport of perishable goods. It consists of a self-contained cooling unit mounted on vehicles that maintains consistent temperatures regardless of external conditions. The device works through a compression refrigeration cycle powered by the truck's engine or an independent motor, circulating coolant to remove heat from the cargo area. Jones patented his system in 1940 after developing it with business partner Joseph Numero. His mechanism includes automatic temperature controls that adjust cooling based on cargo requirements and ambient temperature. The innovation addressed the limitation of ice-based cooling, which melted during long hauls and required frequent replacement. Jones's design featured a rugged construction that withstood road vibrations and varied climates. His refrigeration unit made possible the modern food distribution network, allowing fresh produce, meat, dairy, and frozen goods to travel from farms to distant markets. The technology proved crucial during World War II for transporting blood, medicine, and food to troops overseas. Jones held over 60 patents related to refrigeration technology and founded Thermo King Corporation, which became the industry leader. Modern refrigerated transport systems descended directly from Jones's designs, now incorporating digital controls and environmentally friendly refrigerants. The programmable computer. Mark Dean developed key architecture for the IBM personal computer that made computing accessible to consumers and businesses worldwide. It involves creating the industry-standard architecture bus system that allowed multiple manufacturers to produce compatible expansion cards and peripherals. The ISA bus works by providing a standardized pathway for data transfer between the computer's processor and additional components like graphics cards, modems, and storage drives. Dean led the team that designed this architecture in the early 1980s at IBM. His system includes standardized slots and connectors that let users customize and upgrade their computers without proprietary restrictions. The technology addressed the closed nature of earlier computer systems that locked users into single manufacturers. Dean also contributed to the original IBM PC design and held 3 of the 9 patents for its architecture. His work established the modular approach that allowed the personal computer industry to flourish through competition and innovation. Dean later helped develop the first gigahertz processor chip while serving as an IBM Fellow. Modern computer architecture descended from the open standards Dean pioneered, enabling the explosive growth of the PC industry. His contributions made computers affordable and adaptable, transforming them from specialized business machines into ubiquitous tools. The touch-tone telephone. James West invented the electret microphone that revolutionized telecommunications by making phone calls clearer and devices more affordable. It consists of a thin charged polymer film that converts sound waves into electrical signals with exceptional accuracy and minimal distortion. The device works by using a permanently polarized material that eliminates the need for external power sources required by earlier microphone designs. West developed this technology at Bell Laboratories in 1962 alongside colleague Gerhard Sessler. His mechanism includes a metallized diaphragm suspended above the electret material that vibrates in response to sound pressure. The innovation made microphones drastically smaller and cheaper to manufacture than previous condenser or carbon microphones. West's electret design proved remarkably durable and reliable across temperature ranges and environmental conditions. His microphones became standard in touch-tone telephones, replacing the bulky carbon microphones used in rotary phones. The technology extended beyond telephones into hearing aids, mobile phones, computers, and recording devices. West holds over 250 patents, and his electret microphone appears in 90% of contemporary microphones manufactured worldwide. Modern communication devices rely on principles West established, enabling everything from conference calls to voice recognition software. His invention fundamentally improved audio quality while reducing manufacturing costs. The Super Soaker. Lonnie Johnson invented a high-pressure water gun that became one of history's best-selling toys through innovative pneumatic pump technology. It consists of a pressurized reservoir, pump mechanism, and trigger-activated nozzle that shoots water streams up to 50 feet. The device works by using a sliding pump to compress air inside a sealed chamber, which then forces water through a narrow opening at high velocity. Johnson developed the prototype in 1982 while working as a NASA engineer on spacecraft power systems. His mechanism includes a pressure release valve to prevent overpressurization and multiple chambers for water storage and air compression. The innovation differed dramatically from previous squeeze bottle water guns that produced weak, dribbling streams. Johnson licensed his design to Laramie Corporation, which launched the Super Soaker in 1990 to immediate commercial success. The toy generated over $1 billion in sales during its first decade. Johnson's pump technology demonstrated principles of fluid dynamics and pressure systems in an accessible, entertaining format. His design inspired numerous variations and competitors in the water toy market. Modern high-performance water guns still utilize the pressure chamber concept Johnson pioneered. Johnson holds over 120 patents and used Super Soaker profits to fund his research company, developing advanced battery and energy conversion technologies.